Hello again. I hope you had some time to relax during the coffee break. We will continue with the last sessions of today. And first we will give Tove the opportunity to present her last slides on anthelmintics or replacement of anthelmintics in goats, if I understood well. So, Tove.
Yeah, thank you. This is on behalf of my colleague, Berit Blomstrand, who worked with lambs. And they were treated with extract from pine trees to avoid emeria that cause coccidiose. The treated lamb had lower physical score than untreated, but the extract had a negative effect on lamb's appetite during the treatment. So the conclusion for further perspectives is that this extract may be useful, but it needs further research, and we can just go to the next one and see how the setup was. There was a non-infected control group, an infected group with no extract, and affected group with extract. Thank you. And the result shows that there's a significant effect. The untreated and treated so this shows that it's worth dealing with, an interesting result. I leave it to this and say thank you for your attention.
Okay, thanks a lot, Tove. And then we will immediately move to Håvard, Håvard Steinshamn from the Norwegian Institute of Bioeconomy Research, NIBIO, who will present the work done on vitamins in the RELACS project.
Thank you very much, Bram. This is from the work package 6 in the RELACS project, and the project or the work package leader is Florian Leib, and it was him that was supposed to give this presentations, but I had to step in and try my best in doing this. And together we also have Anja Kunz from the Fontaine Institute, and Florian is from the FiBL Institute. Why vitamins in the organic livestock production in the EU, why this is a problem? One reason is that the lipophilic vitamins A, D, and E, they are usually synthetic products where when using harmful solvents when producing this. And for B vitamins, which is a water-soluble vitamin, it's a challenge that the delivery of GMO-free B vitamins is a technological, logistic, and economic challenge. It is a very expensive production because then the alternatives, the GMO-based B vitamins, they are produced at much higher efficacy and as it costs much cheaper. And another aspect is that on the decision levels is that vitamins are not usually added by farmers, but by premix producer and the feed mills. So decisions on exceptions, regulation, use of products, and supplementation levels are made on policy, the organization, and feed industry, and not necessarily the farmers. That is also aspect with vitamins. Here is an overview of the consumption or calculated consumption of vitamin E and vitamin B2. For vitamin E, it is the cattle that is the great user in Europe in organic production. More than 400,000 kilograms or for young livestock, and about 250,000 for dairy cows. And if you go to vitamin B2, laying hens are the user of vitamin B2. So it's a good reason to focus on those two vitamins. So how to get the levels down? With respect to B2, riboflavin, we wanted to assess the requirement in poultry. We'll come back to that. We also had a focus on how to produce vitamin B2 without GMO-free yeast, and isolate an optimization of a new strain that is not GMO based. With respect to vitamin E, we wanted to assess if it was a possibility to revise the recommendation for dairy cows. When talking first about vitamin B and poultry, in organic livestock nutrition, as I said, GMO-based nutrients are prohibited, and B vitamins are usually produced with modified strains of yeast or bacteria, genetically modified, and therefore organic feed industry needs alternative. This is an issue for vitamin B2, and since organic production use different genetic poultry strains and different feed composition, that is that they are more roughage, it can be questioned if organic poultry have the same requirements as the conventional. So this is the background from the approach. It was conducted altogether 4 experiments with the poultry or in RELACS. And first, I will present this for laying hens. Graded vitamin B doses were fed to laying hens, 3 levels, which represent 166 and 33% of the assumed requirement. And the parameters investigated were feed intake, health score, the egg producing performance, the quality of the egg, and the concentration of riboflavin in the egg. The hypothesis were that the reduced riboflavin supply will not have a negative impact on animal health and performance. And the aim is to build a basis for recommendation for riboflavin or B2 supplementation in organic egg production. And here is an experimental layout. 135 young layers were randomly divided into 3 groups, replicated 3 times in altogether 3 pens per treatment. As I said, 100%, which is 4.5 milligram riboflavin given per kilogram feed. And then we have 66% of that level, and then 1/3 of that level. So I don't going to show any effects results on with graphs, but just summarize the main results. And in this laying hen experiment, they found no relevant effects on health, the behavior, performance, or the egg quality from that experiment. And it was found that the lowest level, 1.5 milligram, resulted in a decreased riboflavin concentration in yolks and livers. The 2 other dosages, the middle and the 100%, did not result in any differences. And it is concluded that the threshold for effects on metabolic riboflavin level is between 4.5 and 3 milligram per kilogram total effective riboflavin in the feed. And that means a supplementation level of extra 3 milligram riboflavin per kilogram feed is safe. That is 66% of current recommendation. If then they did experiment with parent hens, and where they fed vitamin B2 doses to parent hens, 160% of the requirements. And thereafter, the chicks produced from these hens were also fed 160% of requirements. The parameters assess the hatching rate, the egg quality, and the chick growth rate, slaughter weight, and weight of internal organs of the broiler chicks. Again, the hypothesis were that reduced riboflavin supply will not have a negative effect or impact on animal health or egg hatching or performance of the broiler chicks. Again, the aim is to build a basis for vitamin B recommendation in organic parent hen production. In this experiment, as I said, there are 2 levels of vitamin B, 4 and 2.5 milligram per kilo feed. They were divided into 4 pens, each of the groups, and they were fed for 14 weeks. Then the eggs were bred artificially for 2 weeks, and the chicks that were hatched, they were fed, divided into 2 groups for each hen, but they were, as you see that the feeding of them, they were a changeover. So those born after the 4 milligram to the parent, they received 4 or and 2.5. So they also switched to the low level of vitamin B supplementation, and the same with from the chicks that were born after the low level. Some were fed, half of them were fed the low level of vitamin B, and the other one the high level. So to the results, the effective dietary riboflavin concentration of 6 or 8 milligram, that is the 2.5 and 4 milligram supplementation to parent hens, did not affect their performance and egg quality. So the low levels had no impact on their performance. The yolk and albumin, the white in the riboflavin concentration, were not found to be affected either. And neither the egg fertility nor the hatching rate were affected in a way which was traceable to riboflavin supplementation. So that's fine with the parent hen. But if you go to the chicks, broiler chicks from parents with a reduced B2 supplementation grew poorer and had a lower heart rate. All low supplementation of the chicks themselves had the same effect. So on the background of the clear effects on the broiler growth, reduced riboflavin supplementation to parent hens cannot be recommended. So the summary, the vitamin B supplementation experimentation in the organic system, I said that there are 4 different experiment approach with the broilers, which I haven't presented the result from, but from the parent hens and the laying hens, supplementation rates can be reduced compared to common practice, but that is for the laying hens and not for parent hens animals and broilers. So, however, the economic and regulatory problem is not yet solved. That has to do with that there are riboflavin on the market that is not GMO produced. And therefore, as I said in the beginning, the TNN Institute tried to isolate and optimize the growth of new GMO-free G strains for riboflavin production. And they found a strain that has an overproducing vitamin B2 and produced a yield of 30 milligram vitamin B2 per gram biological dry matter, or the growth substrate. This yield per unit of biomass is substantially higher than in the currently offered product that is on the market in the EU. Thus, the selected strain bears potential for far higher efficiency of the production of GMO-free riboflavin. So there are potential here. That is important to say. Then we move to vitamin E for ruminants. Vitamin E is essential and supplementation is often necessary. I will not go into details why it is, but the vitamin E in feed varies and depends on many factors. And for instance, we know that forage plants in a vegetative stage, for instance, pasture, has high content than grass clover silage, which has high concentration than haylage, which has high concentration than whole crop silage, which is higher than hay, and maize silage, and lowest is in the small grain, barley, wheat, and oats, which is important feedstuffs used for the dairy cows. And the current recommendation may be overestimated because the NRC 2001 revision, the North American Research Council, they were based on strong reduction in grazing that in the dairy production in the States, and increased proportion of concentrate and conserved forages like maize silage and haylage in the diet of the dairy cows. But we know that in the organic standards, more than 40% of the daily dry matter intake should be from forage. 50% in short periods in the early lactation, but on general, more than 40% of the daily dry matter intake should be from forage. In addition, grazing is mandatory, so that you should have the cows out on pasture when it is possible. So our approach was to do a systematic literature review to analyze the response to vitamin E supplementation to ruminants and to assess the responses documented in this experimental research, taking into account animal life stage and the composition of the basal diet. So we did a literature research, 2 databases. We had this searching, which I'm not going into detail to say, but we had the inclusion criteria that it should be English peer-reviewed journals. It should be based on in vivo experiments where vitamin E supplementation were given orally as a treatment, and the vitamin E treatment should not be confounded with other supplementation, for instance, selenium or other minerals or vitamins for that sake. And it should be the information about the ingredients in the diet, for instance, the first type, should be given in the papers. A total of 91 eligible references were found. Some articles reported data from the same experiment, and so we ended up with a total of 87 experiments, independent experiments. Of these 87 experiments, 44% were from on health and reproduction, and most studies were conducted during the transition period, late gestation, at calving or early lactation. So most of the studies, and most of them were on health and reproduction effects of vitamin supplementation. So this is the data, and I just will show you some of the results that has to do with during the transition period, which is where they had the most of the studies were done. And most of the studies show that the supplementation had a positive effect on about 2/3 of the studies testing the effect of supplementation of immune status reported improved status, and many show reduced milk somatic cell counts. And it says positive, it means that it increases the vitamin E and the immune status, and also decrease the somatic cell counts, and also reduce the incidences of mastitis. A study conducted in the Netherlands found that cows with high plasma level of vitamin E at dry off, also before the dry period before calving, were more susceptible to get mastitis in lactation when they were supplemented with high levels of vitamin E. In about 50% of the studies examining the effect of supplementation of the incidences of retained placenta and fertility, found improvements in these studies, but also half of them did not find any effects. If you go to during the lactation period, and there are also positive effect of supplementation on supplementation, but it's not as most of them found very few or no effects of the supplementation during the lactation period. We found 5 studies that reported data on vitamin E status in plasma of dairy cows in organic production, and except for 1 study in Belgium, all were from Scandinavian countries, Sweden and Norway, where conserved forages are fed for a relatively long indoor period. 2 studies that had observation during the transition period confirmed that plasma vitamin E drops during late gestation and increase after calving, and that plasma levels in mid and late lactation is high even without supplementation. The experimental studies found higher plasma level in the supplemented cows, but the differences were small. And as I said, very low differences during in mid-lactation and late lactation periods. And it's important to say that these studies, the grass clover silage, were the basal feed. Here is a table showing some study that has reported the concentration of alpha tocopherol in milligram per kilogram diameter in organic produced forages. It shows that grass clover silage has higher concentration, as I said in the beginning, than in maize silage and in hay. And if you compare these figures for the grass silage with what is reported in the review, we find that the reviews shows a very huge variation, but it also shows that the grass clover silage reported from organic produced silages is within the range that is shown. And also please bear in mind that when you calculate the international unit of vitamin E, you have to multiply the tocopherol concentration in forage with 1.49, because in forages it's only the so-called natural tocopherol we find. So it also shows that the international unit concentration is higher than just the concentration of tocopherol. So to summarize the finding we found in vitamin E for dairy cows, that it is needed with supplementation in the transition period. That is the late gestation, around calving and early lactation. And also when basal diet is based on maize silage, hay or haylage, or whole crop silages. And we have suggested a revised recommendation for vitamin E supplementation to dairy cows in organic production. Here's a table showing our suggestion, where we have divided it in the period gestating, that is the last 30 days before calving, and early lactation, that is the first 30 days in milk, and lactation, more than 30 days in milk. And our suggestion is that it is similar to what the INRA feeding system for ruminants published in 2018 for most of our recommendation, and it's lower than the National Research Council. The part where we deviate from the recommendation in INRA is that during lactation, when they are more than 30 days in milk, on pasture and fed grass legume silages, we think that there's not necessary with supplementation at all. When they are fed other conserved forages, and that is maize silage or hay. Yes.
We have to finish in around 1 minute now.
1 minute. I go to the last slide here. In short, synthetic lipophilic vitamins, vitamin E, cannot be completely phased out from organic livestock feeding, but reduction is possible. And reduction of vitamin B2 supplementation is possible in diets for layers, but not for breeders and broiler chicks. And GMO-free supply of vitamin B2 from controllable European sources is possible and existing. But the economic and policy issues hinder current broad application of GMO-free supply for vitamin B2 in Europe. Thank you. Sorry for me breaking the timeline.
That's all right, and thanks for finishing on time in the end. There's a question from one of the people in the audience to share the links of the reports that were shared in this session. So all speakers that are now with us in this session, if you have any specific reports to share on antibiotics and anthelmintics in particular, then please do so in either the Zoom chat, or if you can in the Hubilo chat. If you do it in the Zoom, then we will share it with the audience. And then we will go to the next presentation that is from Federico Righi, University of Parma, a researcher in the Organic Plus project, and he will present the work on novel bedding materials. So Federico, the floor is yours.
I will share the screen. Okay. Okay, can you see the screen properly?
No. We don't
see
yet.
The screen. Maybe now?
Yes, perfect.
Okay, very good. So within the Organic Plus project, we performed also a couple of studies in order to test novel bedding materials of organic origin, of course, in comparison to the traditional, let's say, bedding, which is mainly given by straw or wood shaving in poultry. So the studies were conducted on poultry and on just a second, and on poultry and mainly broilers, and on dairy cattle. Let's start with broilers. On broilers, we performed an experiment involving 252 Ross 308 broilers, divided into 9 boxes with 3 different treatments, different bedding, wood chips. Actually, it would be better to say wood shavings, poplar pellets, and vineyard pellets. So since the box were 9, and with 3 treatment, we had 3 replicates per each treatment. So the experimental design was basically a complete randomized block design. The materials used as bedding were tested for their composition, and we can see here in this table that basically they were very, very similar concerning the content of fiber expressed as neutral detergent fiber, the content of lignin, and also the content of ashes were very similar between the 3 beddings. But the format, as I told, was wood chip wood shaving, poplar pellets, and vineyard pellets. Poplar and vineyard were organic bedding, and the wood chip wood shaving were basically the control conventional bedding. Okay. So first of all, the consumption, we noticed a big difference between the need for adding, let's say, so the use of wood chips and wood shaving in comparison to the pellets. Probably this is related to the density of these materials. So of course, pellet is very, very high density bedding, very solid, very rigid, while wood chip are softer, and less dense. They fill the volume very easily, and they are more soft for the animals. And the same difference was found when we expressed the bedding consumption per kilogram of live weight of the animals. Some macroscopic measurements were about the cleanness of the animals. I think that first of all, bedding should guarantee a very good hygiene of the body of the animals on the bedding. And we can say that we evaluated the foot pad score, the HOC score, and the plumage cleanness score with a scale from 0 to 3, where 0 was the best output and 3 was the worst output. That means dirty animals or dirty animals for plumage, or lesions in the hock or in the foot pad. As we can see, the output was quite similar at the interval of 42 days for the 3 parameters considered, with some differences actually in the HOC score, with better results for the pellets. Okay. And there were more differences at 84 days, which was the final measurement before slaughtering, with better scoring in general for the wood chip. Concerning the humidity of the bed, which is something that deals with the behavior, if we can say behavior of the material, we can see that the orange line that describes the variation in humidity of the bedding, we can see that the wood chip or wood shaving were undergo bigger variation in humidity. Probably this is related to the density of this bedding. So lower density, so easier, makes the evaporation easier. So they were absorbing a lot of moisture when there was some manure on them, and then they were drying very fastly after this increase in humidity. They were drying very fastly, so they were going through bigger variation in comparison to the pellets of Wynard and Poplar. Something similar was found also for the temperature. Let's say then that when the environmental temperature were lower, the temperature of the bedding made of wood chip and wood shaving was decreased fastly, and during the most let's say fresh period. So in May, for instance, in this case, and during the month of May, while after the increase of the environmental temperature, the bedding made of wood chip wood shaving was higher in temperature, increasing the heat stress on the animals. On the other side, the Poplar and Wynard pellets were more consistent, let's say, with the temperature, and they had lower variations in relationship with the environmental temperature. Mortality was almost the same for all the groups considered. Little bit lower, if we can say, for Poplar, little bit higher for Wynard pellets, but at the end, no significant differences were found in the frequency of death in the animals. And basically no differences were found also in the body weight at both 42 and 84 days, even if we have to say that the body weight was numerically higher for wood chips and wood shaving and Poplar pellet in comparison to Wynard pellet at 42 days, while pellets were better, I mean animals on pellets were performing a little bit better at 84 days of fattening period. Okay, dairy cattle then, and then we will make common conclusions. We performed a study on involving 36 animals divided into 2 groups with 3 replicates per group on a tie stall, which is not really organic, but it was better from a, how can I say, from a study point of view, because it was easier to monitor the animals. The animals were fed a hay-based diet, and the study was performed at the end of July for a period of 10 days, comparing conventional straw, so conventional bedding made of straw, with organic wood chips produced by the ATB in Germany. We measured basically hygiene scores on the animals, behavioral traits, including standing and lying periods, other behavioral traits like ruminating, eating, and drinking. And also we measured something about the behavior of the bedding, as I said before, in particular the humidity. And we found that the humidity during the trial was lower in general for wood chips, and for wood chips all along the period, while the humidity was a little bit higher with straw. So the conventional bedding was able to keep more the humidity, and this is not necessarily positive, of course. Concerning the hygiene score, we found better hygiene scores both for the body and the udder in the animals on wood chips, with significant differences in the average score during the period. Of course, the score is 1 to 4, with 1 the better, the cleaner animal, and 4 the dirtiest animals, or cleaner udder and dirtiest udder. And concerning the behavioral traits, standing and lying, we measured the behavior of the animals for 48 hours every 15 minutes. So at the end, we measured the frequency with which we observed standing or lying, and we found no differences between the 2 groups of animals. We measured also the frequency in ruminating, eating, and drinking with the same design, and we found no differences also in these behavioral traits. And concerning milk production, we had a milk yield that was similar, with no differences in total bacterial count and coliforms count, even if I have to say that the values, the average
Federico,
values.
can you also please wrap up in around 1 minute?
Yes, okay, I'm done. We found lower values, average values for total bacterial count and coliforms, even if not significantly. But we found that a trend for a higher contamination with Clostridium butyricum in the animals, in the milk of animals on wood chips. And this is very negative, especially in our region where we produce Parmigiano Reggiano cheese, and the Clostridium butyricum is a huge enemy in our production. Okay, so at the end, what we can conclude is that broilers, concerning broilers, wood chips seems to be better than pellets in the short period. And pellets perform, organic pellets perform in a very similar way on the animals. There were no significant effect on performances. And at the end of the fattening period, pellets seems to be positive. I'm referring to the 84 days interval, seems to be positive, even not significantly, in the performance of the animals. Concerning dairy cattle, we found lower moisture on wood chips, cleaner cows on wood chips, no impact on behavioral and milk production, behavioral traits and milk production, even if wood chips gave a higher contamination with the spores of Clostridium butyricum, as I said before. So in the milk. In any case, wood chips seems more effective in keeping animal clean, even if the contamination is still a problem. And with this, I thank you very much for the attention. Okay.
Okay, thanks a lot.
Welcome.
Okay, good. Federico, can you unshare your screen and we continue with the discussion?
Yes, sure.
And we'll go back to the first presentations about antibiotics. There were a couple of questions that we did not address yet. And the first one is about the content of the bark that was analyzed in the Organic Plus project. So Carmen or Federico, could you elaborate on what was the content of the bark and the green tea extracts that you used?
Okay, we basically measured the antioxidant capacity of these extracts using several methods, and we referred mainly to the ABTS, because ABTS allows for a direct comparison with vitamin E. And at the end, we adjusted the doses of each extract in the broiler diet in order to achieve the same, to obtain the same dietary antioxidant capacity of the control group that was receiving vitamin E. This was our choice because we found we made several reviews about this, and they are already published. We found that most of the authors in the past were testing plant extracts in doses that were not, with using doses that were not explained from a rational point of view. They were testing an amount that probably was believed to be economically sustainable, probably. So our choice was to equalize the animal diet for the antioxidant capacity using appropriate levels of these extracts. We didn't do any other analysis, not chemical analysis on the extract, because I think that the main goal was to achieve the antioxidant, the same antioxidant capacity in the diet. This was the rationale behind our work.
Yep, thanks a lot for explaining that. Then comes a question for Michael from Ivana Turkulia. She asks about the efforts that are needed to phase out antibiotics. So we have done, research has done a lot of efforts already. What are now the real bottlenecks to phase out antibiotics?
Oh, how many hours do I have to explain now? Well, to try to make it short.
1 minute.
Well, okay. This is always the question to solve all problems of the world. But to make it short, I think the main focus must be on preventive measures. So we have, for example, starting with breeding, but also all around feeding and housing, and in specifically impact will have all the milking management and hygiene, as mastitis is for sure an infectious problem normally. And on the other hand, medicinal plants or plants with active ingredients may have some influence on the solution of mastitis, mainly on the high somatic cell count, not mainly on the clinical mastitis. As long as we feed them, there is some evidence. We don't test it in this project, but in other projects there is some evidence. And maybe for the long term, the direct application, the local application might of secondary plant metabolites or essential oils might be another interesting idea, but it is in the very beginning of research.
Okay, good. Thanks a lot, Michael. I need to come back to Federico because it seems that the question was not fully answered yet. Actually, the real question was, what was the type of bark? Which tree species did you use? Okay,
this actually was a commercial product. I can say also the name if you want, but it was a commercial product made by the hydrolysis of wood residues from pellet production. So mainly it was poplar wood, hydrolyzed poplar wood. So they obtained polyphenols from this raw material. Very cheap raw material. Because it's a byproduct of other productions. So we found it very interesting, and we were advised by several stakeholders to try this kind of product.
Okay, good. Okay. Thanks a lot. And I invite Berit, if you have more questions still, then you can get in touch directly with Federico and discuss more about this.
My pleasure.
Then we go to the anthelmintics topic. Spiridula, there is a question to you about how did you supply the header to in vivo experiment? Was that also header extracts, or were that header plants, and how much did you supply?
Yeah, so we allowed the animals to eat on heather, so they were given a heather to eat, and in the two studies we had a different approach. So in Switzerland, in the experiment, I hope I'm not making a mistake here, and if I do, maybe Veronica can correct me. They were allowing the animals to eat heather in addition to other food. So heather was fed as a supplement. But in our study, the animals were, for the period of heather testing, the animals were eating only heather. Because we wanted to see how much they would eat. And heather intake was, in both cases, offered ad lib. But in one case, it was offered as a supplement, and in the other case, as a sole feed.
So the animals were grazing outside in an heather?
No. The animals were indoors, and the heather was cut and offered to them to feed indoors.
Okay. Good. You mentioned in your presentation, Spiridola, that you would also like to investigate other bioactive plants, so not only heather, but what other plants do you have in mind? And would this Artemisia that Tove presented also be an option according to you?
Yes, so in the life of this project, there will not be time to do anything more, but certainly plants like the Artemisia that was mentioned, and other plants basically that are rich in secondary plant metabolites are certainly contenders for that. There has already been a lot of work on certain types of plants like grazing forages, for example, like Sala and chicory. But certainly there are options for places in the world where heather is not available. Basically, that's what I'm saying.
Okay, good. Thanks for this. Tove, a specific question for you is how much Artemisia the pigs actually consumed? It was not very clear
10 grams per pig.
some of the people. So if you can.
It was 10 grams per pig. It doesn't sound of very much.
Good.
So that was 10 grams per pig per day?
No, only 10 grams per pig. One day.
Okay, one day. Okay, yeah.
Yeah.
Thanks.
One day. Okay. All right. Then we go to the topic of the bedding material. It was not very clear to me, and perhaps also not others, to why the bedding material that is currently used is still is considered contentious. So why is there a need for replacement?
So can I answer?
Yes, please, Federico.
Okay, basically we were answering the call of the Horizon 2020, and contentious because the bedding we are using in most of the organic farms is still of how can I say, still of conventional origin. So for instance, we are using straw in bedding for organic dairy cattle, for straw that is coming from conventional agriculture. Okay, so the point was to replace this conventional. Conventional means that can have also chemicals residues, you know. So the goal was to find alternative full organic bedding materials. And they proposed from ATBS in Germany, Ralf Petzenka is our co-worker, let's say in this case, our colleague. The proposal was to use poplar or vineyards pellets from organic agriculture. So we tested this bedding. And the same in poultry. In poultry, we were using I apologize, we wrote wood chips, but it's more wood shavings. We use wood shavings from conventional wood used in the industrial processes, and this is not organic. So we tried organic alternatives. And again, they were, in this case, pellets from vineyards and poplar. For dairy cattle, we use the wood chips from poplar. So yes, alternative bedding of organic origin. That's it. And actually, if I have to comment about this, we can say that the main difference was not, especially in the trial we performed on dairy cattle, was not really between organic and conventional. It was more between straw and wood chips, which are quite different materials. But this is related to the availability. Basically, what we were told is that there is a higher amount of organic wood chips than of organic straw. So we decided to try organic wood chips because it's more available basically on the market. So the use of wood chips is an indirect effect of the organic need. There is more is a substrate that is more available. So this is what this is what drove our choice.
One more question about the use of bedding material. You said at one point that the mortality of the broilers was 13%, which is very high. Is that, how would you compare that to conventional litter material, or what would be the reason for this high mortality?
I would say that in this case the higher mortality was more related to the not use of antibiotics. We had we had some colibacillosis infections, and we decided, since we were trying to simulate an organic poultry livestock, broiler livestock, we decided not to treat with antibiotics, so we had higher mortality. This is what happened actually. We of course, the stocking density of the animals was the one of the organic regulation, but this was not enough to reduce the mortality actually. So we did our best to keep clean the environment, to keep clean the mangers, the drinkers, but at the end, the impossibility to use antibiotics increased the mortality. Okay, this of course this was related also to our specific experimental setting, but it was impossible to reduce the mortality without antibiotics. Okay, this is not really related to bedding. I think it's more a general issue in the system, let's say.
Good.
Did I answer your question?
Yes, I think it's very clear for me. It was very clear. Håvard, a question to you about the vitamins. So your research and that of Florian and colleagues has shown that it's possible to reduce safely to reduce vitamin supplementation in the feed. So what are the current obstacles preventing this reduction?
Well, it's twofold. The one thing is that I think you can answer better for me than the vitamin B, because that has to do with price and the policy. Vitamin B are produced without GMO strain, but the price is very high. That is one thing. But as we've shown here, that there are potential to improve that efficacy quite strongly, and then it's up to the industry to take up that and to commercialize that. So that is one thing. Another thing is that this is also up to the feed mills and those who are making the feed that are bought to the farm. For instance, usually the concentrate or the vitamin and minerals are supplemented through the use of concentrate for mixture for the dairy cow and also for the poultry. And that is also, I think it's a kind of an insurance thing for the feed mills, that they are I think that this is a kind of a cheap insurance, even though there's a cost for them, but instead of getting that get a problem that farmers experience that. And of course, one thing is that it is very difficult to know the exact levels, for instance, in the diet of the dairy cow or cattle, what is the vitamin E. So that is also a strategy too. But I think that we have good the rational reasons to recommend the reduction in part of the production cycle for dairy cows and cattle. That is very from the review we did, and those, not many, but those studies that has been done on dairy cows and vitamin E supplementation in areas where we feed the cows for a very long time indoors in Sweden and Norway, which is clearly show that we have not much effect of supplementing the cows in mid and late lactation when they are fed high quality silages. I don't know if that was an answer to your question.
Yeah, I think it's a very good answer. A question to Carmen and Michael. If I understood well, the essential oils were supplied through the mouth in Organic Plus, while they were applied to the other in RELACS. Do you want to comment on that, or do you see a difference? Or why is one way better than the other? Or
well, if I can start, it is just two completely different ways of application, and for this reason also not comparable. But when you have clinical results, well, we have to wait for safe clinical results. On the other hand, in our case, it was the application form which was used traditionally from the French farmers. So we choose this application form. But well, there are a lot of possibilities also to give it orally.
Okay. Carmen, do you have anything to add there?
No, I think it's that we use two different ways to administer the product, because the we want to have a different effect, no? For mastitis, it's more locally that you usually apply any treatment.
Mm-hmm. Okay, good. It seems there are no more questions from the audience. I can double check. No, so everybody is still for the remaining 5 minutes invited to post questions. Perhaps people in the panel have some questions to each other, so feel free to ask your colleagues.
Maybe I can comment a little bit on the use of essential oils per os. Okay, we didn't test the use of essential oil per os in this case because to test an antibiotics you need a challenge somehow, no? And we are not. I mean, we are not allowed in this moment, and it's very complicated in Italy to make a clinical test, let's say, with a challenge on animals. So we didn't want to try an experimental infection and to test the antibiotic activity of this product. So we decided to work mainly in vitro as a first approach. So we tested the minimal inhibitory concentration, and we tried to cross the data with the tolerance on intestinal cells in order to find the balance between the antibiotic activity the antibiotic activity concentration not toxic for the intestinal cells. Okay, so we need to cross. We need to keep an equilibrium, because essential oil can be very aggressive on intestinal cells, and we have a experiment from the past showing that the performances of the animals can be very, very deeply reduced by the use of essential oils per os in the feed. So we need to find the right amount that express antimicrobial activity without damaging the animal. I don't know.
But maybe
I'd like to comment.
Yeah, we have to keep in mind that these essential oils, or even further, the different combinations of secondary plant metabolites which are offered in herbs, spices, or medicinal plants, are more than pure antibacterial or antimicrobial. So when you look in the broad spectrum of ingredients of only one essential oil, then aspects of reducing biofilm activity, for example, or reduce or in elevating or stimulating the immune system, and further aspects we have to consider when we do such clinical research. And I'm absolutely with you, Federico. We cannot use it in such a high concentration that we have direct antimicrobial effects. I don't think that it is possible, maybe externally, but not internally. And so we have to have a look at these components broader. But nevertheless, it's an important in vitro result which you received from your research, also, Carmen. Yeah.
Thank you very much.
Good.
For your comment.
I see there is one more question from Tove to Federico about the occurrence of flies. Did you observe any effect of the bedding or difference between the bedding materials on the appearance or the presence of flies? Sorry,
presence of what? Sorry.
Flies.
Flies. I see. We didn't make any observation about this, but I can tell that at the end of May, the amount of flies was very, very high. But actually, all the animals were in the same room, let's say, the same environment. So we cannot have a classification of the number of flies based on the bedding, because they were all in the same pen, let's say. So yes, interesting anyway, very interesting, yes. But there was a large amount of flies actually.
All right, good. Then I think we've come to the end of this session. It seems there are no more questions. So then we go to the wrap up of today. So both projects will have the opportunity to say some last words for today before we go then to the next day tomorrow. The first will be Judith Conroy at the Coventry University from the Organic Plus project.
Hello, everybody. Yeah, I've had a fantastic day. It's just brilliant to see the breadth of work that's going on in both of our projects, and the variety of stuff that we're doing, and how far we've come in these 3 or 4 years. I suppose the things that I'd probably, some of the themes that I've picked up on and perhaps like to highlight is, I think a few of us have started to kind of question whether it's actually replacement inputs which are needed, or whether it's more broad system design. And even then it might be a combination of both. Obviously none of this is simple. So it's not just about the substitutes, it's about maybe considering whether we need those inputs at all, or whether there are other ways of doing things that may be better. And I think also that situations vary a lot. So for example, in the case of the heather that Spiridula was talking about, it varies from country to country, different climates, different seasons. And the same with the Norwegian spruce that Berit was looking at. So I think, I think in different parts of the world, in different localities, in different climates, there might be different solutions. So it's not going to be a one glove fits every hand in terms of the solutions that we've got. I think it's also good that quite a lot of people are looking at using waste products. Obviously, we need to be careful with those and check the quality of them, but the use of resources that might otherwise go to waste is good as well. And I think that there's obviously a lot of variety. Some of the contentious inputs I think are closer to being phased out than others. So the mineral oils, it's obviously quite complex, but it doesn't seem that we're maybe that far away from that being phased out. And then some things such as antibiotics, there are questions over whether they should actually, obviously we should minimise their use, but should we actually phase them out at all? I think something I've been working on, I'm lucky to be able to, as well as have an overview of the Organic Plus project, be active in one of the work packages, so the soil work package, and I'm quite interested in peat. And I know certainly in the UK, we are getting closer to a complete phase out of peat. And I think the momentum's possibly building in some of the other countries. We still need to do research on that. We still need to maybe scale up the production of the peat-free alternatives, but we do have some very successful replacements that have been around for a number of years and that growers have been using consistently. So yeah, I've got some kind of notes that are all over the place for that, but that's my sum up of the day. And yeah, I'm really looking forward to what else we've got tomorrow. And I think the other thing with tomorrow is to see how kind of the things like the modelling and the life cycle analysis and the more maybe kind of social science aspects come in as well. So the public perceptions of of contentious inputs, and how kind of this practical work that we've discussed today, how that fits in with the modelling side, and how we actually do phase out contentious inputs. So yeah, thank you very much, everybody. It's been really enjoyable.
Thanks a lot for these words and for your nice summary of today. And then I also invite Lucius to share his perspective of what we've learned today.
Thank you, Bram. Of course, it's it's quite a challenge to add to what Judith was just saying. So maybe to add to what you said, we've seen that the contributors in both consortia were really have come up with an enormous wealth of approaches and solutions, and some of them are quite far advanced. I've also observed that those solutions are at very different technology readiness levels. So some may be ready to implement. Technically, they might be adopted as by tomorrow. Others are take more time, or still others, like the essential oils, for instance, strike me that the proof of concept has not yet been quite given, whereas in other technologies it's clearly there, like the heather or in the peat, all the alternatives to peat and so forth. What also strikes me that we have been, both consortia have been brave enough not to address each and every possible solution, even though we knew exactly that robust varieties are key to any strategies, or we know as well that functional biodiversity is key to many solutions, but we were brave enough to know it, but not to address it in addition, because this would have diluted our resources too much probably, and these aspects are addressed in other ongoing projects or just projects that are just finalized now. We also see that there are very different timelines for implementation for many reasons. Some are technical, some are regulatory, some are logistics, depend on logistics, which have to be built up before introduction of the solution. We've also seen that in some cases, the outcomes may be very relevant for conventional farming systems as well, whereas in others, like say the vitamin replacement, may be of little relevance to the conventional farming, but in many cases it's very relevant. I haven't seen in the presentations yet, and this is because both projects started and were designed before Farm to Fork. We haven't really addressed yet what the expected growth of organic farming, what relevance it has to our logistics and our replacements of these inputs we are addressing here. So it's quite easy to speculate that it will be even more pronounced. But in some cases, we may also experience economy of scale effects, like in the litter arena, so to speak. And then it popped up several times, and I guess we will address it tomorrow in more detail. That's the aspect of bottlenecks of implementation. In some cases, let's say if we have a solution which is close at hand or even ready to be used, why it's not adopted. And this, of course, depends on the various bottlenecks which need to be addressed or need to be resolved at some stage. But this needs careful insight. But we have come quite far, I think. First, we need technical solutions before we can even think of introducing them into farming practice. So for me, it was a very interesting day, and thanks a lot for all the presentations. They were really excellent, and it was also very interesting to see how the same thing can be approached from different points of perspective.
Okay, thanks a lot for these nice words, Lucius, and also a big thanks from my side for all the presenters of today. I've learned a lot also myself. Yes, tomorrow we will continue. As Lucius said, we will go more into the bottlenecks, and we will also see what is the consumer acceptability of the solutions that we have investigated, and acceptability of the farmers, by the farmers. So it's of course very crucial that whenever we propose a new solutions, that every body buys into that and understands what it's about and can accept it. So it's a very important discussion that we have to have with the whole sector. And we will also look into more detail of what would be the socioeconomic impacts and environmental impacts of some of the solutions we've been investigated. So what is the impact on the environment? What is the impact on the price and the cost structure of the farmers when implementing new alternatives? So I'm looking forward already to tomorrow, and we see each other then at 9 o'clock. And in the meantime, I wish you all a very pleasant evening.
Thank you. Bye, everyone.
Thank you. Bye.
Yeah.
Federico.
Bye-bye.
Thank you. Goodbye.
Bye.
Bye.
See you all.
Yeah. Bye.